area. Similar idea here. We're just talking about a part of the circle. We're talking about the area of the part of a circle. So let me just highlight it to give ourselves this visual. If we're talking about the sector area, we are talking about the area of this part of the circle. So again, if we think a little bit of logic here, we're talking about less than half of the area of that circle. Same deal with the one that is in degrees over here. Okay, we're talking about the area of this part of the circle. And in this case, this one is also less than half. Okay, so let's look at the formula. The degrees is just like the arc length formula. The only thing that's different is instead of circumference, we've got area. Because again, we're talking about a portion of the whole circle. So we're talking about the portion of the area. Okay, this is the portion part. Is it a third? Is it a fourth? Is it 5/6? What part of the circle is it? And we multiply that by the area. Now, again, because of simplifying, the radian equation looks a little bit different. But what ends up happening is there's a pi in the denominator, because there's 2 pi radians in a circle, like there's 360 degrees. We talked about that last week. So there's a pi in the denominator, and then your area is pi r squared, so those pi's cancel. So that's why the formula for the radians looks the way that it does. But let's just use those formulas, okay? So the first example that we have here is with radians. So let me just jot down the general formula to start with again. So theta over 2 times r squared. We're going to use S for the sector area, just like we use S for the arc length. We're still just talking about that piece. So theta here is 5 pi over 6. We're dividing that by 2, and we're multiplying it by the radius squared. We're going to do what we did just a minute ago. We're going to put in everything but the pi. Now, you do need some extra parentheses in there. That's a fraction, 5 over 6. Put it in parentheses, divided by 2, times 10 squared. It's going to be a fraction, so go ahead and do your fraction thing. 125 over 3. We just put the pi back in the numerator. If we want the decimal, then we multiply that by pi. Notice you can try to put that in fraction form. It is not going to put that in a fraction because pi is an irrational number. It cannot be expressed as a fraction. This is area. So our units here are squared. So here it's centimeters squared. Let's make sure that makes sense. What's the total area? Area is pi r squared. So here that would be 100 pi. 100 pi is 314.159. So that's the total area. Ours is less than half, so it's got to be less than 157. So 130, that makes sense. Okay, let's do one that's in degrees. So let's jot down the formula in general. Theta over 360 times the area. Area is pi r squared. So for our specific case, using the angle from a minute ago instead of 150, 150 over 360 times pi times 7 squared. Put in everything but the pi. 7 squared is 49. Forgot to turn it to a fraction. 245 pi over 12. Kind of weird, but it's weird. Doesn't mean that it's not right. So 64.141. And this is square kilometers. To make sure that it makes sense, what's the area of this whole circle? 49 pi. 49 pi is about 153. Again, we're less than half, so we've got to be less than 76, but in the general neighborhood of 76, we're not significantly less than 76. We're closer to that than to a quarter, right? Notice these pictures, they're kind of inverted, but we're actually talking about the same portion of both of these circles. 5 pi over 6, 150 degrees. They're actually the same. Let's do a quick flashback to last week where we convert radians to degrees or vice versa. 5 times 180 divided by 6 is 150 degrees. So these two angles are actually exactly the same. If we wanted to convert 150 to radians, we would multiply by pi over 180. So 150 over 180 is 5 pi over 6. Okay. Just reviewing really quickly, radians to degrees to radians to show that these are actually the same portions. Obviously, they're different circles, so that's why our answers were not the same. But I just wanted to point out that we were talking about the same portion of each of those circles. One was in radians, one was in degrees.